Okay, so I'm going to be venturing a little bit off of the normal subject matter that I tend to deal with about another little hobby of mine, especially one that I'm utilizing closer we get to Christmas. This is a longer Ray 5. It is an engraving laser, and it is kind of an entry level diode. I've had a lot of fun with it. The one thing that I don't really like about it is that the size is kind of limited. It gives you about a 400 millimeter square work surface, which actually I don't even know that it can really reach the 400 millimeters, but it says it can. It's kind of a stretch on the cabling as is to do that. Anyway, so it's been a good little machine. I've had good results with it, but I need a bigger machine. I do mostly very simple projects, which this diode works just fine for, but I need bigger projects than this. Longer has an expansion kit that will take it out to 800 millimeter on the x-axis or y-axis. Okay, you guys need to know which axis is which because I mix them up unless I've got it on the computer. If I say the wrong axis, I'm sorry. I think that this is the y-axis and that's no, it's the other way around, isn't it? X-axis, y-axis. Okay, Longer has a kit to expand the y-axis to 800 millimeter. Costs about $80, and I considered that, but I want to go a little bit bigger than that, and I think I could, do it for less. I haven't tried this before, so we may fail. I'm going to post the video regardless whether it succeeds or not. But I don't think I'm going to fail. I think that this is going to be pretty simple. It's just a matter of swapping some parts and doing a little bit of soldering. So what you are going to need, I am going out to 1 meter on the x-axis. I want the x-axis to be longer, which means that we're going to have to expand both of the frame bits and also the carriage for the laser. I don't want it to be deep, I want it to be wide. In the area that I work in, it really doesn't matter which way you go. It's just the area that I work in, the way this machine is set up, it would be easier for me to, do it the other way around. I think, really looking at it, maybe not. Maybe it'd be about the same. But we're going to do it anyway. It's going to be hard for me to get my control panel over here on the side if I rotate it. We'll see how it works. We'll just see how it works. So, all right. You're going to be able to, you can actually go, 1 meter square, or you can get these things in 48-inch lengths, which I think is like 1.25 meter, something like that. Can't really remember. It's just a matter of multiplying everything and having the right components on hand. With what I'm doing, I needed 3 of these 1 meter 20 by 20 aluminum extrusions. You want V-slot. All of these machines are V-slot. You want V-slot extrusions. You will also need timing belt, which if you do much 3D printing or if you have your own lasers or anything like that, this is a wear item. It's going to wear out eventually. It's good to have this stuff on hand. The extrusions are, I got 4 of them for $40. The timing belt, I want to say that this is 2 or 3 meters, and this was $6. You will also need wire, I have lots of wire because of my other projects just laying around. And you will need a 5 millimeter rod if you are extending the carriage. If you're not extending the carriage, if you're going, with the depth, you don't have to mess with the rod. But because I'm extending the carriage, I gotta have the rod. Finding a 5 millimeter rod that was a reasonable price was kind of, tricky. This is 3/16 that I could get from Home Depot that I think will work. We'll find out. It's very close to the stuff that's already on there. These aluminum extrusions, a lot of them, they come with these M-lock style mounting tabs. I don't think that I'll need any of them, but it's convenient to have them. You will also need basic Allen wrenches, which I think that you'll be able to get away with the Allen wrenches that you had on the machine whenever it came to you if you were doing this longer Ray 5. Now, this is something else, is that this is going to apply to pretty much any laser that uses these 2020 aluminum extrusions. So you can expand the cheap ones or the more expensive ones. All right, so step one, we're going to loosen the ends of our legs here. So I didn't think about it until just now, but the bores on these are drilled and tapped. So you'll also have to, do some drilling and tapping. There's some machine screwing. The screws that come with it are steel, fine thread. Probably get away with just winging it. We'll see. Okay, so now the last bit is going to be this one. We'll need to loosen our collar here. This is the collar on the timing rod for the, God, I'm going to keep saying it wrong, x-axis. You'll loosen that up, and then this carriage should come off. we're going to go ahead and take the laser off. That way there are no accidents with the laser. What am I missing over here? No. Might have. Trying to do that. Oh, this wrong one. This also is the wrong one. Apparently I am missing an ounce. Find the one that's bigger than this. All right. Yeah, that's what I forgot. It's like all of these have little anchors on the insides. I expected that to come off, but it did not. All right, so all right, now we'll have to take the legs off. Not that big a deal. I think that my timing belt is, yep. The timing belt goes to a little slot on the ends of the legs, and then we're just adding a little bit too much tension when you get through there. Alright, so what we'll do then is move that down that way, and we'll go ahead and assemble our longer sides. Oh, oops, that goes on the inside. And again, you make sure that what you get are V-slots because, alright, let's take a look at this. Longer cells, they have these anchors that go on the inside. And all of the other mounting hardware is V-slot, not T-slot. And I don't know that they're compatible. Some people have told me, yeah, it works either way, and others have said, no, it's different. So I'm going to err on the side of it's different. And not risk it. It's funny, this includes a lot of, I was thinking I might be able to use these because it includes a bunch of T-slot bolts, but they are, or T-slot nuts, but there's no bolts. It goes through my little baggie of stuff over there. Make sure there's not any bolts sitting on the inside. As the T-slot mounting nuts aren't by themselves all that helpful. All right. And they are, at least they're the right size for this, but we need bolts. May have already come to a standstill because it includes, they do include their own little brackets there, but they didn't include the bolts, which is, well, it's a lot of fun. All right, let's see if we can improvise. Don't always like improvising, but sometimes it's necessary. All right, I know how to improvise. Okay, so it's not the most elegant way to do this, but by golly, it's going to work. All right, so each one of these things, each one of the legs has 2 bolts. And what we are going to do, because the bolts are going to be too long to go through and actually tighten the legs on, we are going to go and do it this way. I'm going to put 1 bolt on the inside and 1 bolt on the outside of the leg, like this. And then we will install the leg, snug it down as much as we can, the bolt itself, and then we will tighten that down with pliers. Alright, let's get those in there. Let's get the timing belt through the eye. Alright, now we gotta loosen this up. So we just have that on there by hand. Hand tight. There we go. Actually, no, because it's so long, it's causing some droop to come into play. So we will have to, where's these two bolts? Have to square it up after we get it all assembled, which is fine. You should make sure that these things are square at that point anyway. That's something worth mentioning. Let's see if we can get this on camera. V-slot anchors. This is what they look like. There is a V on one side and then a raised portion. The V goes in the inside. The raised portion always points away from the extrusion. Little things like that just aren't in the instructions. Because the instructions assumes that you already know what you're doing. Or that you're not going to read the instructions anyway. And who knows? Both assertions might be right. All right. So now you take the control panel off and get the rest of that leg off. Part of our frame is assembled. This is going to be the length. Width. Guess it depends on your perspective. The length, width. Which wrench is it? Is it this one? No, it's not that one. That's the little one. I got too many Allen wrenches here, and I can't find the one that I need. Oh. Yeah. That might help. See if that washes out the video. Nah. It's a nice warm light on it. Okay, so now this, I don't remember how this goes together. Oh, wait a minute, yeah, I do. Because it doesn't use an anchor. It screws into the extrusion, because the extrusions are tapped. I don't know why I'm having a hard time remembering that, but boy am I. Once this is loose, be able to slide that off. And then, same thing, we'll double this up. Hush. Nobody's here, you're fine. Panicky dogs. Oh, wait. It's got to go through here first. Okay. Now we've already got that loose over there. these things over here. Alright, so now we're actually ready to start. Scooching things together. Oops. One side down. Okay, so now this side is going to be just a teeny little bit trickier. It looks like I was worried for no reason. No, that's another thing. So like getting these little M-lock style tabbies to tighten up, you kind of have to pull them towards you a little bit, give them a little tug in your way. So now that I've got the frame extended, I'm just going back and making sure that all my corners are nice and met flush. They'll need to be snugged up. And then tightening up our anchors. Inside anchor, whatever you want to call them. I don't know what to call those things. The little doohickeys. Alright. So now, this. And this is going to be, I think, a little trickier than the others because that's actually longer than the frames down here, and I did not realize that. So this is going to be interesting. Either I'm going to have to take these back apart and cut them to make this up here work, or I'm going to have to come up with something else. We'll see. So, but it's nothing for it. You keep moving forward. I bet actually, I think that that'll work. I think I'll have to take my ends back off, but I think that will work. I believe that I might be able to reverse this. And then that will put me close enough on the inside. We'll see. Might be able to reverse both, where I'll lose a little bit on the inside, but not that much. All right. First thing I need to go ahead and do is loosen these up. I think that's part of a sagging problem I've got. This is trying to, it's too heavy, so it's just trying to fall the whole time. Unplug that. The stepper motor is actually pretty robust. Heavy, should say heavy. Man, those are nearly 2 inches longer. Did not realize but probably should have. Alright. So let's start with this. The wrong one. Loosen up the nut on this collar so we can get our rods out. I actually think that they're, no, it's steel. Oops, let's do it this way. Fits through the bearing very nicely. Of course I would do that. Oh, it'll be easier if we just go ahead and do this. I forgot to put the belt over the rod. I'm going to do it like that. All right. All right. Loosen this one up as well so I can get some play over here. Okay. Yeah, see, it doesn't get the full carriage because it wouldn't. I guess it would be pretty close to that 0 over here. All right, so let's see how we can make this work. Now, I don't really like the idea of where's the bolt? Don't really like the idea of cutting the ends down. So I'm going to come up with a way to extend this the necessary distance. We're going to get a little scoochy all the way back. Which that's not going to be a common back either. This is going to be a tricky part. One of the tricky parts. All right, so here is what we are going to do. We are going to measure this versus the sides. Let's see how much longer they need to be. All right, had to go find my caliper. Okay, all right. Make sure those are flush. They are flush. One point six seven five. 1.675. 1.675. Gonna have to write that down. 1.675. 1.675. 650. 650 is 5/8. Something like that. Doesn't matter. Okay, so that's what we got to, or not shave off, what we got to add to this. Let's see, how can we do that? We do have these. This won't work. That's not going to work. I can take, let's see. We'll have to think about that for a minute. Okay, so making our cut. All right, so we got to have a bit of extra to span the gap for our X-axis trolley. And this is going to be the best way to do it. We're going to just cut some of the stock 2020 material from the original assembly. And since this is aluminum, you can do it with a good chop saw. Make sure that you have a really sharp blade and that you cut slowly. And we've already got our mark on here. You guys will have to, know exactly where you're going to mark, and where you're going to cut. Yep. And like I said, cut slowly, have patience, make it very clean. Then, so long as you got a nice sharp blade, you will get, there's not even any flashing on this. It is a super clean cut, and this is going to be perfect for spanning that gap. Another thing, let's go back over here. Don't know where. Nope, hold on. Okay, so the factory longer ends are threaded and our new ones are not, but a standard 3-inch wood screw threads right in without much drama. What I do with my screwdriver. So you'll have to have some patience, and it's going to be better to do it by hand. And yeah, so instead of having to have a tap and die, or just a tap to drill out these to run the bolts that longer uses, you can actually get away with using a wood screw. It's not as pretty, but it will be just as strong.
be working on than songs that are skipping ahead.
Okay, so we got our trolley going. Now, because not all of these 2020s are going to be exactly the same, you will probably have to adjust the tension on your track. The way you adjust the tension on the track, this wrench should have come with your laser. It's also the same as most 3D printers. Anything that's got these types of wheels on this type of extrusions on the, let's see if we can move around here to the back and get it on the screen. This wheel on, yep, that's not on the screen at all. Let's get, yeah. Behind this nut on the other side of the plate, there is another nut, and you can loosen or tighten that to adjust your tension. You're going to want it to be, easy to move around with one finger, but not so sloppy that you could slide it all the way down without much effort. So if you're just swapping it over, like this is just slightly bigger than the factory extrusions, so it was kind of snug. I had to loosen it up to where it could get like this. Before it was very tight, and you could actually feel like little imperfections in the wheels, which means that whenever it's trying to slide along the belt, it would translate into this and affect your print. Okay, so the last two things that we need to do for the assembly is we're going to set up a belt, and we've got to get our limit switch mounted. We're going to do the belt first. Sometimes changing these belts out is the easy thing to do, sometimes it's the tricky thing to do. Part of me hopes it's the easy thing, and also part of me kind of hopes that it gives me trouble. That way we can demonstrate how to fix it. All right, so what I think is the best way to do this is to feed it through from the other side. Feed it all the way through first. And then we'll set up the anchors. Kind of like to say that this is the way that I like to do it. I really can't think of any other way you could do it. And like, even if like if you anchored one end, you'd still have to feed it all the way through. Oh well. Alright. Up in there. I like to only have maybe 1/4 of an inch of material on the outside down there. Okay, so we've got to steal the anchor bolts off of this, which I took one of them off and now I don't see it, so that's fun. I'm sure it's over here somewhere. I had to move everything around so we could have dinner. Now I can't find some of my stuff. Okay, so this is the same kind of extrusions or anchor. It's the same anchors that I showed earlier, and it's going to go with the the sailboat side or curved side goes down, the little raised indentation goes up. Getting these to set can be tricky. I'm going to see if I can get our camera over here. We can get a good look at getting, there we go. I'm not used to my phone actually being cooperative to zooming, but it's a new phone. All right, what to do with it? There it is. So, what I have found that works is putting the oh, there it is down there. What I've found that works is putting the anchor in place, roughly, and then we're going to use a screwdriver to set it down and rotate it. Getting this stuff to rotate is where it's usually problematic. And of course, this time it works beautifully without any problems whatsoever. Worked so well, it actually tried to turn right back out just from loosening the thing up. So, yeah, that went super easy. That's usually one of my least favorite parts. All right, let's do that. And it's down there. Hopefully this is just as smooth. Not gonna be if I do it that way. There we go. All right. And after you get that situated, you're gonna pull the trolley from one end to the other, move it slowly. Make sure that you don't feel any binds, and make sure that your stepper motor turns easily with every step. It's not missing anything. You can actually, this is what I was talking about with the difference. You can see right there at the end, it moves a little bit faster because it's a little bit looser on this section, but with the size of the laser, we're probably very seldom going to be all the way down there, and it will only touch that. Barely. Okay, so we've got the trolley on there, and we have the belt installed. Now we need to get our limit switch in place, which is not on this one. and save these belts because they are good to have extras of. Okay, so our limit switch we're just going to get it kind of set in place, and then we'll confirm the distance. Whoops. Righty tighty, lefty loosey. Except for whenever it's the other way around. Alright. So, this does not have to be super precise. You just want the motor, the trolley, to stop before it runs into anything over here. Fantastic, that's in place. Plug the power back in for that one. Fantastic. Okay, so the last thing to do is going to be wiring. Well, other than, this, trimming that off, and I'm going to trim off the excess bar over here. I think that 3/16 is going to work just fine, I think. Just pull this back up. Okay, put that with it. This was a new in the package belt. The package was messed up, so we are gonna store this in a new Ziploc bag. Is that I have a lot of printers, and I may expand this this machine out again, make it a little deeper. So, spare belt is going to be a good thing to have on hand. All right. So, the next thing is down here on our laser. I wanted to point this out. This is something that I just noticed, is that the sheathing that's rubbing on the little clasp here, wearing through. So that's going to eventually wear through into our wires, and it's because it's allowed to wiggle. And it's going to cause problems with that cable. So nothing in the instructions said to secure this, but whenever it goes back, it's going to be tied really tight to this. All right. Let's go back out. This is just for the sake of the fun of it. Where's my bolt? Whoops. Okay. There it is. Because there was some concern that this would cause it to bow this much weight. And I mean, I'm having to push pretty significantly to get it to flex. And it's definitely not flexing from the weight of that. All right. So we're going to start by unwrapping our cables a little. And we got a 4 conductor and a 9 or 5 conductor. And they are not color coded, so that's going to be fun. Alright, we'll gather up some solder and some heat shrink and start cutting up wires. Okay, so wiring. Wiring is probably going to be the most intimidating part of this project for most people. Wires, they tend to make some people nervous. And I'm going to try and demonstrate that it's doesn't have to be all that big a deal. So you will need, as I discussed earlier, you will need some wire, you will need some solder and resin, flux. I always call it resin, but it's flux. Probably. They do make some flux core solder. I don't like that stuff so much. I like solid core resin. Solid core solder. All right, and some shrink wrap is very handy to have. Pretty necessary for this. Otherwise, you're going to do a lot of taping and it's going to look stupid. Okay, so here we have 2 cables. This is going to be for the stepper motor and this one's for the laser. We have 9 conductors total. What would be convenient is if you had a ribbon cable that could that had at least 9 conductors of the appropriate gauge. I really don't know what gauge these are. Not very big. I think 22. Not really 100%. Wait, because I checked this and they matched. What was this? 13 gauge? No, that's not right. Doesn't matter. Actually, it does matter. You don't want to be too small, but it's going to be hard to get too small with this. So the wire I'm using is this 4 conductor cable that I've had laying around from some of my other projects. I pulled off enough to stretch with the laser all the way over there, all the way over here, plus some, and I took it all out of the sheathing. I am going to use some more mesh cabling or cable sheathing to contain it eventually, and I am also going to maybe rig up some drag chains, or there's going to have to be a means to manage the cable, because whenever we're all the way at that end and this is stretched, it's not a big deal, but as the trolley comes back, it's gonna be too easy to bind up. So usually this is either suspended from the ceiling, or you can use a drag chain that will push it off and pull it back and forth as needed. Or a lever system. I'm probably going to use a lever, which will be an arm mounted. Let's get up here without burning myself because my soldering iron's on. An arm mounted on this end that'll be on a spring that goes about halfway. That's gonna lever up as the trolley comes closer and lever back down the further away it is. That works in some larger applications just fine. It should work in this one without a problem. All right, we have all of our materials. I don't need Allen wrenches or any of that. It's best to get anything that you don't need out of the way. And because none of these cables are marked, so it's one red cable and 4 black cables on the 5 conductor one. And I'm assuming they all go to specific places, so we have to keep all of that in order. All right, so we are going to start with the laser cable. And because both of these cables are set up the exact same way, with one red conductor and multiple black conductors, we're going to have to do, one at a time. I generally am a very strong proponent of prepping all of your wire beforehand to where whenever it comes time to solder, all you have to do is solder. But because there's going to be all these cables that are all the same color, I'm going to say no. In this instance, we're going to do the laser cable and have that complete, and then do the stepper motor cable. Completely eliminate the risk of there being any kind of crossover. All right, then before we get started here, I'm going to give each of my wires a little twist. A little twist. Since I'm filming this, I expect none of these to solder cleanly. All right, yep. Red didn't get down in there. He thought he was gonna get away with it. All right, so we got some stuff on all of those. And I am going to pull one red conductor to match our red conductor, one white conductor because, one green conductor because, one black conductor because, let's see here. We need 5 conductors. 1, 2, 3, 4. We'll do 2 blacks, just to keep it simple. All right. I took these all out of the sheathing beforehand because the sheathing, one thing, it's 4 conductor cable, so I would need, two lengths of cable plus 1. So I would either have, 2 lengths of sheathed cable plus 1 extra cable or conductor, or I would have 3 lengths of sheathed cable, and it's too much. The sheathing is very rigid and stiff. It would make the cable too stiff. All right. So what we're going to do to start with, I'm going to try and step over here and make sure that we're still in frame because I did move my camera. Looks like it. Okay, so we are going to 1 conductor at a time. We're going to go ahead and get some solder on them. It's always better to do in a garage or something where you have good ventilation. I am going to do it in my kitchen where I have good light. Because if I'm going to pump my lungs full of nasty smoke. By God, I'm gonna see it happen. All right, so let's go ahead and move all of these over here. All right. The reason why I pre-solder all of my conductors which ones am I missing? Red. Ow! Because once these are all soldered together, or once they're all pre-soldered, you have to do to actually get the cables connected. You just have to give them a little heat and touch. It's so much easier to do. Yeah. All right. So now on this end, we're just going to kind of wing things a little. Oh, this is something. All right, so I cut my cables long enough to where this end can be secured with the solder point staying stationary. The same as whenever you've got this moving, you don't want a soldered connection to be moving a lot. You want these ends fixed. You only want the wire to move. If the solder point can move with the machine, that gives you a potential breaking point. We don't want break points. We want good, solid connections. Good, reliable connections. Man, I wish I had a hotter soldering iron. Of course, I said, hey, all it takes is some heat. Man. All right. Give her a little twist, add a little more solder. I'm sure there's some soldering pros out there who will eventually see this and go, "You're doing it wrong." Come on. Man, I don't know why that one wanted to be so ornery. Okay, let's pick green. I don't like the way that one looks so much. So we're gonna try to get that to smooth out. Nope, it ain't gonna do it. Oh well. It looks like it's got a good connection. I just wish it was prettier. Alright, so since we got two black ones, I'm gonna separate the black ones. Black in the middle, and then white, and then black on the outside. I'm gonna have to make a little holder for my stupid soldering iron. Alright, that one's got good contact. White. Ow! Stabbed myself. Always best to avoid doing that. Come on. You can do it. I will always find it funny that it can get so hot that I can't hold the wire, but it can't from, several inches away. But I gotta add pressure to get it hot enough to transfer on there. Okay, last wire. All right. Let's go ahead and get some shrink wrap on those. Just a little bit of slag, shaving off. Make it a little bit easier for my shrink wrap to fit on there. This one, my slag just had a little bit of a bump. And we can cut off this other side. Don't need no slag. Nope, that one tore a hole on one little part because a little piece come up. So we're going to cut off that little sharp spot, a little lump over there. And still got good connection there. Ta-da! My bad. You also need a lighter or a torch, something. Just to shrink the shrink wrap. Okay, so and here is a tricky bit. Actually, we're going to we need 9 conductors covered overall. Before we go to hooking up this other side, we're going to go ahead and put the shrink wraps on. We're going to go one, put it down there. And then green is 2. Sorry if some of this stuff is taking place off screen. All I'm doing is sliding our shrink wrap on and trying to maintain in my mind where, which wire is what. Okay, so there we go. All right, so now we're going to go to our plug for the thingy that does the thing. Actually, I got nah, we're not going to do that. Thought about putting a couple big pieces of shrink wrap to cover the shrink wrapped connections. Not going to do that. All right, and then these, I'm not going to pre-solder these because that normally is what I do, but I'm normally working with heavier wire and a torch, and I find that that's a lot easier, but it didn't seem to save me any time, and I still had to add even more solder afterwards, and since the wires were soldered, they were a little bit more difficult to twist together. So I'm going to goop them up with flux, twist them up, and solder that way, and see if that works a little bit better. Some wire is just a pain in the butt to solder, and maybe that's what I'm dealing with here. But just in case, we're going to try both and see which way is easier. I said I've got a standard practice, but it didn't seem to save me any time here. All right, so we're going to start with the red one, because that one's the easy one to track. All right, let's go. Get that all twisted up. Nice and neat. Did I unplug? No, that's still plenty hot. The dog's over there having a nightmare or something. Okay, so second wire is the black wire. It goes in the square hole. Get that all over there. You want that doubled up. I don't want that. All right, let's pull that back out. That might be hard to get underneath our shrink wrap. Let's cut off that little bit. And it's actually, I mean, it's going together a little bit faster. And considering this has to be done with your head pointed down at a weird angle. No, black is the middle. Okay, black is the middle. And it goes in the square hole. Make sure that this doesn't get mixed up. Okay, fourth wire is the white wire. And the white wire goes to the black wire. Hope you don't mind that joke, because you're going to hear it like a lot. And the last wire is the black wire, and it goes to the black wire. Mm. Okay, so after you get one run going, before you cover that noise up, it's going to be better to trace your wires and go through each one. Like, so green is the second wire. We got green on the second. And then this black one should be the middle. It is the middle. White is fourth. And the black wire goes to the black wire. All right, so now we pull our shrink wrap down to our solder points after we have confirmed our work. That one. All right, let's get our other ones in place. Okay. All right. And our connection for the laser is done. And only took a lot of time. How much time did that take? 34 minutes. My gosh. Okay, Stepper motor. Need one of them fancy wire strippers that you just got the thing, you go, and it knocks the sheathing off. My soldering iron out of the way before I burn myself again. Might sound like a silly thing to try and be cautious about, but after you've been on fire 3 or 4 times, it's hard to be too cautious. Your brain starts saying, fire's good and all, but let's keep it over there. Okay. The red wire goes to the red wire. Add a little weight there. Come on. Come on. Oh, I didn't flux these things up. Let's get them all fluxed up. Bloop, bloop. Bloop, 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 bloop. Mm. Okay. No, don't twist those together. I'll make that a little easier. Okay, so since we've got red, black, white, and green, we're going to do white as the number 2 conductor, and then the green number 3, and we're going to put 4 on the end. Black on the end as number 4. Since it's the 4th conductor, of course it would be on the end. Oh, come on. There. That'll work. Because actually for this one, it doesn't really matter. So if you get your colors different than you planned, setting up one end, it's not a big deal. Just do the other end the same way. Oh, also something to keep in mind. If you're somebody who likes to bite your nails, nervous tendencies, things like that, don't do it while you're soldering. I can tell you from experience, flux tastes awful. Probably gives you cancer in some places. And if you're married, try not to be caught soldering on your wife's countertops. Okay, let's get some shrink wrap on. Actually, there's, you can already see on this one, that one's going to give me fits. So let's go ahead and cut that tail off. And the same, I saw another one right there. Okay. All right, so now let's, man, I had a piece of, there it is. Go off on a tangent because I'm going to start humming songs. There's something on this. Saw a band from Lubbock last night called Blackwater Draw. Apparently they are relocating to Nashville to pursue their dream. We've seen them a couple times now. If you're along the East Coast somewhere, they do a lot of, they're primarily a country band, but they do a lot of mixed music, Eagles, Stevie Ray Vaughan, and their own works. It's a fun band. Had fun watching them. Took my kids. That's a good thing. A good thing. A thing like that. I was able to go to a show like that I could take my kids to. Can't always count on concerts being super kid friendly, but this one was. These guys they were a lot of fun. Okay, so now, okay. So red, it's number one, goes to the red wire. Oh crap. I'll have to make sure that I put my shrink wrap on each one. The red wire goes to the red wire. Lost my solder. Okay, so red is number one, white is number two. You guys are gonna have to remind me to put my shrink wrap on, since I didn't do it all up front. White is number two, and it goes next to the red. Lots of smoke. Okay, so green is number 3, and it goes to the black wire. It really makes me wonder. They couldn't get multicolored harnesses. Lost it. Couldn't get it to balance here. All right, and then black goes to black wire. It goes in the square hole. Video that made a little bit of a viral run a couple of years ago. Just Google goes in the square hole. It's fun. I forgot to put the shrink wrap on it. Okay, all right, so same as before, we make sure that we are wired up correctly. Got red, white, green, black. Red, white, green, black. Run that all the way down. Red, white, green, black. Okay, I think I got it right. I forgot to put the shrink wrap on the last 2. Oh man, that's gonna be problematical. Make sure I. Darn it! Dag nabbit. All right. We'll do it the old-fashioned way with those 2. Not proud of it, but we're going to use tape. I hate it. If I were a professional, I would unsolder this connection, cool it off rapidly, put the missing shrink wrap on there, and put it back together right. But because I am an amateur, I ain't gonna do it. All right. So that is both of our connections. And we are an hour deep into just soldering. I've had to do this in 2 or 3 different segments. It's probably going to turn out to be something like a 5-hour-long project. Getting this all set up. Come on. It's going up. Okay. So now we're just working on making it a little neater. Just a little bit. We're not going to invest too much time and effort in this part. We will make it the neatest after we're certain it works. Alright, so I'm going to show you guys a trick from back in the original Fast and Furious days, whenever all of us cool kids needed lights on the bottoms of our cars and sound systems. And had to wire, had to run 150 feet of 16 gauge cable all over our 1999 Honda Civic. Works great if you got a power drill. Alright. That's all we really need. We don't need a whole lot of twist going on in there, because that also shortens out how long our cable is. And our factory cable took almost all the twist. Man, I'll have to undo some of that. I should have expected that to happen. So don't do that. Will work fine if I clamp this down. Didn't damage anything. But it'll be alright. This is all going to be in a sleeve eventually anyway. Alright. So let's get that set up. And remember what I said earlier, that I discovered, that was getting torn, and also we don't want our soldered connections to move around a lot. So we are going to secure this. It looks like I got enough room to secure it right there. All right. so right above the stepper motor, there's a little hole that I can use to anchor that. Like I said, this is going to be more difficult on this side, but like I said, this is going to be, there's going to be an arm over here. This is going to be secured to that. That arm is going to probably come about here. It'll be on a spring that will move back and forth with the cables. Alright, so in the meantime, that's all of our connections. Let's go and grab the power supply right quick. Okay, so we'll get over here where we can view the whole thing. Alright, so we've got it at the opposite corner. We're going to make sure that the switches, they are connected. We're going to go with control. We're going to send her home. The most important thing is the making sure that this is going to track properly. I'm really not concerned at all with the uh-oh, looks like it's not moving. What did it? Oh. Homing fail. Please unlock. Huh. Homing fail. Please unlock. Looks like it might have a little bit of trouble with the additional length. Alright, so let's yeah, okay. So I will have to figure out how to overcome that. It does not like the additional width here. I don't know what this does. Alright, so you got an idea here. Let's go back to control. I got a job we can set up the framing for. Okay, so this should be, let's go back, engrave this one. And this would also let us be able to see the laser, because it uses the laser to actually test the framing. And it's a big file, so it will probably take a while. Soft limit. No. I really hate that. Alright, let's move it here and here. I'm sure that there's some way to fix the soft limit thing, but every time that I have encountered it, it like really argues with me. I reset the home and it's like, no. Yeah, that's going to be because the file's bigger than the original frame bed. Okay, so I'm going to have to, I got to do a little research. We'll be back. Okay, so basically I had to, connect it to my computer, run a little cable over here, get the laptop set up. I can say that I picked the Ray 5 because I wanted that user interface down here to where I could put my jobs on the card and then keep my laser in the garage and do all of my editing and building in my office. So if you're normally running it from the computer, you probably already knew this. We are going to have to go to, let's try, because I don't really know what all these are. Okay, right here. So the x-axis is 400 millimeter. So 130 equals 970. I'm not going to go to full 1,000 millimeters. 3. I don't know if I have to write this out fully, but we're going to find out. Axis, I haven't had to do this before. Let's see what happens. Bad number format. Let's just try doing it just like that. Okay, so now let's go with 130 equals, and it shows the 970. Okay, so now okay, so we're gonna just back this out so that we can see the thing. I am just manually moving it over and making sure that it goes past the original soft limit. Whoop. Already had problems with the cables, which I knew was gonna happen. Okay, so now it says 850. Okay, so hard limit is at 900 now. All right. So now we are going to send it all the way home. And it made the full travel, no problems. Okay. So now, whoops, shouldn't have hit the button there. Okay, so we are at the hard limit now. I am, whoops. I know you can't see what I'm doing. I'm just manually moving it back over. What I'm wanting to do is measure what my full travel is. So I expected it to be around the 970 mark. I sure hope I didn't push that button too many times. And I did. Alright, we're going to move it all the way back over here. gonna turn it back on. All right. We are gonna reconnect. You guys can see what's going on. What do you mean disconnected? Oh, reset that. All right, COM4, connect. We got it. Oh, that's not what I wanted to do. Okay, so we're home. Yes. Set our home. How did it do that? Okay, so that should be our home. We're going to go out to 800 millimeter first. Actually, that should put us at 400 millimeter. You'll do it in small chunks first. Okay, 400 millimeter. This should move us out to 800 millimeter. The basic, we're moving as far out as it'll go, so I can program in the maximum travel. Okay, so that's 800. That's 900. All right, let's turn this down. It's 905, 906, no, 10. We're gonna say 910. That was at the bump. Okay, so 910 millimeter. That's where we got with, let's get lunch out of the way. All right, so 910 millimeter is where we got with the 1 meter bars. Let's get zoomed in here so you guys can see what we're doing. Okay, so this is what we do. That is the x-axis. So x-axis, and this is in laser GRBL. Okay, so we're going to type in under this type G code line. It is $130. Let's make sure that that stayed the same. All right, stayed at 170 or 970. So to change it, we do $130 equals, and this is where you put your maximum travel. Our maximum travel is 910. We're going to say 910. That gives us about 5 millimeter buffer. So we're going to say $130 equals 910.000. Enter. And it will come up with a little green check mark next to the value that you entered, and that means that it has accepted what's going on. All right, from here we are going to hit disconnect. We're disconnected. We can disconnect from the computer. We're going to go back out to the machine, and we're going to make sure that our firmware has actually stuck. So we're going to turn it off. I'm actually going to move it back just a little bit. Let's bring it back on. We're going to go with control and send her home. Fantastic. Okay, so we are going to go to Alright, so I should be able I can't ever remember if that stacks. But I should be able to push this as much as I want, and it will reach the soft limit before it reaches the end of travel. Fantastic. Okay, so we reached the end over there. It's not going any further. And won't hit the little doohickey. Let's bring it back home. The only thing that we haven't tried yet is the laser. We've got all of our motion in place. Okay, so we are gonna scooch her out here, and we're gonna go get you guys a little bit closer, looking down. That's the way this thing squares out what it's gonna shoot. It actually uses the laser at a very low setting. Nope, oh, that's not what I wanted. Oh well. This. I see home. I think I'm supposed to hit that and it goes back to the home screen, but that's not what happens. All right, so our laser fires up. Beautiful. Okay, so we got one last thing to do, and then this video is a wrap. We're going to get it back out into the garage, set up on the bench, and we'll do an actual cut on film just to confirm everything is done and works. Okay, so our last little bit just to confirm that everything operates. And I don't have a job that will use the full width. A lot of my stuff is coming up for Christmas, so the jobs that I have ready are Christmas presents. And my family watches my YouTube channel for whatever reason. We look at this. I just I'm using a rubber band for now. I will rig up an arm with a little spring on it in the future, but this will do the job for the time being. Alright, so I've got this one little job that is a star. We'll set up to cut. Alright, let's go ahead and set up our focus. That's all good. Alright, let's go with star. Set our frame out. Whoops. Oh yeah, that's right. That star was huge. Let's try a different one. Okay, so we got a little Christmas tree instead. Now let's go back into engraving. Pick the tree. We want our 0 there. Let's frame it out. I'm going to be able to get this whole thing on this little piece of scrap wood. It's lit up all the way around. Not quite, but oh well. Okay, so I can't remember what my settings were, so we're going to say 2 passes. And it's just blowing through this wood, so we're going to pick up our speed a little bit. It's still just blowing right through that wood. There's a little Christmas tree ornament that I set up, but I didn't really like it in the end. So that's one thing. Turn on my air. I can see a lot of flames going on inside. Oh, yeah. Scorched a little bit there. This might be a good example of what it's like having air assist versus not having air assist. It might be a good example of why my air assist sucks. Alright, we don't really need the whole job to be done. Okay, so I got most of it out. I was messing with my power a little bit, so this the first little bits of it didn't cut. That's alright. It's just a test little scrap anyway. Almost cut all the way through it. Right there. But this is a good example, especially in the thinner spots. This was no air assist. This had the air assist on. But obviously it's working, it's doing its thing, and it's now twice the bed size that we had to begin with. So I'll be able to handle some much larger projects that I'm really looking forward to. All told, this project probably cost, it was $50 for the rails, $6 for the bar, and probably all said is going to be right around the $60 mark US to double this. The wire was mostly scrap that I was able to put together, and yeah. So if you want to duplicate this is how to do it, and you can drop me any questions about it you want. I will do my best to help. Thanks for watching. Bye.